Computer science. We're going to use array lists and for each loops to implement a searching algorithm where we search an array list for some data. So what kind of problems can we solve using a searching algorithm using an array list? So we can answer the question, does the array list contain an element that meets some requirement? So if you have, let's say, a list of products, we could answer the question, are there any products in this list that cost less than $100? We can answer the question, how many elements does it contain that meet the requirement? So same example, if we have a list of products, we can answer the question, how many products are less than $100 using a searching algorithm. We can also answer the question, what is the biggest or smallest element? So with our list of products, we could identify what is the most expensive product in this list, or what is the cheapest product in this list? These are the kinds of questions you could answer using the searching algorithm. And this is it. Or this is not it. This is a product. So for this example, we will be using a list of products. So this is just a snippet of the code product. It will have an instance variable called price that's a double, and it has a method called getPrice. And this is the only information we need. So I've got a comment down here saying that the other constructors, methods, and instance variables are not shown. So we would assume this code would actually have many more things. You might have the name of the product, maybe some sort of category. Is it snacks or kitchenware or a toy or electronics, that kind of thing. But for all we are concerned about for our problem is the price. And on the exam, when you're answering a question, you'll be given code like this. That's basically, here's some code. This is all you need to know about it to solve the problem. So all we really need to know is that there's a getPrice method that returns us the value of price. It's a getter method for a product. And we've created a type called product, so that will make sense for us. All right, so we're going to write this method called has affordable product. And I've got a comment. It's pretty straightforward what we're going to do. We're going to return true if stuff, which is the name of the list, is stuff, contains at least one product with price less than the limit. So we don't know what makes something affordable. It's whatever values in limit. It could be $100, it could be $1, it could be $1 million, whatever that limit is. And our list of products is called stuff. And so we're looking through that list. We're searching that list for products that are less than limit. The price is less than limit. So here's our plan. This is the algorithm. We are going to create a variable to keep track of the answer. Okay, so we're gonna, like usual, you're writing a method. This method returns something. We want to create a variable that's going to hold the value that we will return. After that, we're going to iterate over every element of the list. In general, if you're writing an algorithm that involves a list, you will iterate over all of the elements of the list. If a product is identified to have a price less than the limit, then we'll set the answer to true because we found it. We found a item that is less than the limit. And then at the end, we will return the answer. So the first thing we want to think about is what should the default value of the answer be? So we're creating this variable to store the answer. We're going to store some value in it. The way you should answer this question, because there's two choices, right? It's going to be a Boolean, so it's going to be true or false. The way you should think about this question is, if the list was empty, if there were no products and stuff at all, what should this method return? So that means that loop iterates over. There's nothing to iterate over. So all this code really does is create a variable and return that answer. What should that answer be? If there's nothing in the list, does the list have an affordable product? That's the question you want to answer. And we're going to say no. If the list is empty, then it does not have an affordable product. It doesn't have any products. So of course it doesn't have an affordable product. So we're going to set that answer to false. And I like to think of this kind of problem as it's false until proven true. So we're going to start by saying this answer to this question, does the list have an affordable product, is false, unless within the loop I can prove that it's true, in which case we'll change our mind and say that it's true. So I don't have to check in this case if the answer is false. We're only checking if it's true, which will override our original default answer of false. All right, so we're going to put together this algorithm. We're going to convert the plan into code step by step. We're just going to work through the plan and convert that into code. So the first step of this plan is to create a variable to keep track of the answer. Pretty straightforward. We make our variable. It's a Boolean because this method header has a return type of Boolean. So I didn't have to think about that. I just copy Boolean over, give it a name, answer. It's going to be my answer, so I call it that. And then assign it the default value, which we decided is going to be false. So that's step one, make our variable. After this step one, I actually like to skip all the way down to step 4. So I make this variable, and the first thing I want to do after that is I want to return that, which is the last thing I want to do. I like to do that first, especially when writing by hand, so that I don't forget. And because it's a common thing to do on the AP exam is you spend all this time writing this code, answering this question, and you forget this real easy thing at the end to do, and then you lose one of your points, which is a bummer. So I just way at the bottom, I just type return answer. I made my variable answer, I return it. So I know now at least I don't have to think about that. That step is done. Then we bounce back up to step 2, which is to iterate over every element of the list, which obviously we're going to use a for each loop because we just learned about for each loops. So pretty straightforward. If you've got a list, you're probably going to iterate over it. So for parentheses, product P, colon, stuff, end parentheses. Put your curly braces because we're going to put a bunch of stuff in there, whatever we want to do in this problem. So I got this from a product is the type of the array list. It's an array list of products. Stuff is the name of the array list. So neither of those two words that I have to think about. I just copied them from the parameter declaration. And then P is a variable I got to invent. P because it's the first letter of product. If stuff was a better name, if stuff was actually called products, I might have said lowercase p product as my variable name there. But since we called the variable stuff, I didn't have a good name to give it. So I just called it P because it's the first letter of product. So it'll be pretty obvious to me in the code what P represents. So that's our iterating over the loop or iterating over the list with a loop. So now we have to actually do something within that loop. What we're doing is we're checking if the product identified, P, this is the product we're looking at, if it's identified to have a price less than the limit. So we're going to use an if statement. If we're identifying for checking something, we're using an if statement. We're checking if the price of P, so I call that getPrice method, p.getPrice, is it less than limit? If it is less than limit, then I change my answer to true. That's it. That's the whole thing. So where did all this stuff come from? I just want to do some arrows here. So P is from the for loop, product P. That's the element that we're able to look at in this loop. It's the one we're currently iterating over. GetPrice is a product method that we're allowed to call. Limit came from my parameters up here because that's the thing I'm comparing to. And then answer was that variable we declared at the beginning. So that's where all these things came from. I didn't just like invent all that. All of this stuff came from other places and we're just kind of combining it to come up with this check. So I can read this for each product P in stuff. If P's price is less than limit, then the answer is true. The answer that stuff contains at least one product because we found one product at least, if that was true. And then once that loop is done, we've iterated over every element, we will return our answer. If any of the elements were less than limit, then we would have set the answer to true, and this will return true. If none of the elements were less than limit, then we would return false because that was our initial value, which is exactly what we want to do. Now, this is what the code is supposed to look like. There's a common way you can make a mistake here, which especially if you're rushing through your answers, you might write something like this, which seems like it makes sense. So if we look at this, this is saying the only thing added is this red part. So for each product in P, or product called P in stuff, if the price is less than limit, set the answer to true, else set the answer to false, right? Because if the price of the product is not less than the limit, then it's the opposite of this, right? So it's either true or false. But This doesn't work. I'm telling you, it doesn't work. I want you to think about it for a minute. Maybe pause the video and just go, why doesn't this work? Actually, before you pause it, I'm going to give you an example. So I want you to work through this example where I'm telling you, let's say the limit is $5 and stuff contains these values. So $2, $1.50, 99 cents, and $75. Why does this code in the red box give you the wrong answer, where I argue that the code we came up with originally would give you the correct answer? And of course, you want to use your human brain and eyes to look at this and say, well, what is the correct answer supposed to be? Then trace the code like we've practiced, and identify what this will actually return, and see that, oh, they're not the same, or they are the same, right? It worked or it didn't work. I'm waiting for you to do it. You can pause the video if you need more time, though. All right. So why doesn't this work? This doesn't work because as we iterate over it, we look at the $2. So answer starts false, right? We look at the $2 and say $2 is less than $5. So we set our answer to true. Then we look at $1.50 and we say, well, $1.50 is less than $5. So we set our answer to true. Then we look at 99 cents, which is less than $5. So we set our answer to true. Then we look at $75, which is not less than $5. So we go into the all else and we set our answer to false. Then our loop is done and we return our answer, which is false. And a false answer means that there is not at least one product with price less than limit. However, there are many products with the price less than limit here, so the answer should have been true. That's why this code in the box doesn't work, because this code in the box is really only looking at the last value, because the last value will determine whether the answer is true or false, regardless of what any of the other values are, because of that else statement. Okay, that's why I consider this kind of problem a false until proven true problem. If we use the code that we came up with earlier, we say answer is false, and as we loop through, we're only checking if the price is less than limit. We don't care about anything where the price is greater. So in the original version of this code, this would set answer to true, this would set answer to true, this would set answer to true, and then when we got here, the if statement is false. So we wouldn't do anything to answer. And then we would return answer, which is true, because we only ever set it to true inside the loop. And so that's the difference between false until proven true or having an if else. You never, ever, ever want a loop where you have an if and an else that set your answer to true and then false. This will always fail you. Okay, you definitely want to do it with just an if statement inside your loop when you're solving this type of problem. All right, so other kinds of problems we can solve. So that was searching for an item, an element that met some requirement. So now we're going to try to count products that meet that requirement. So now we want to know how many products have a price less than limit. So the same method header, I changed the name and I changed the type because this is a how many problem. Instead of returning a Boolean, it's going to return an int because we're counting things. The answer will be a number. Since I changed the type of my answer variable, I changed the default value. And the default value of a how many problem is going to be 0. And you can figure that out asking the same question. If there were no products in the list, what should this method return? And if I'm asking how many affordable products there are, and there are no products at all, then there are no affordable products because there aren't any products. So our default answer makes sense to be 0. And then the rest of the whole thing is the same, except for in the if statement, we check if price is less than limit. How we manipulate the answer variable is different because instead of changing it to true, we increment it with the plus plus operator. Or you could say answer equals answer plus 1. Plus plus is less code. So you can see only the red things changed to convert from code that's searching for at least one element that meets a requirement to counting how many elements meet the requirement. We changed very little between those. It's just paying attention to the type. What exactly do you want to return? Similarly, if we look at the problem where we're looking for the smallest or the largest, then we're making a similar number of changes. So again, the method header changes here. So I called it get cheapest price. We're going to look for the smallest element in the list, or in this case, the element with the lowest price. Okay. This method header doesn't have a limit because we don't care about a limit. We're just looking for the item with the smallest price. The type of this method is going to return as product because we're returning the product that has the smallest price, the lowest price. So our answer type changes to product because it's going to match the method header. And then we have to think about what is the default value for this going to be. And before we get to that, let's look at the other changes. We also changed the if statement. So the if statement used to be p.getPrice less than limit. We don't have a limit because that's not what we're concerned with. We're concerned with some other price, the price of the answer. And then we return the answer, and how we change the price is going to be different. We're actually going to talk about this if statement in just a second. I just looked and saw that. That's the next slide. So let's figure out the answer to this question. What should the default value of answer be? So in this case, I want you to think, what if there's only one product in stuff? So for this particular question, we're not going to worry about if there's no products in stuff. We're going to assume there's at least one product because it wouldn't make sense to find the cheapest product in a list of nothing. So if there's only one product in stuff, then what would our answer be? What would the cheapest product be? And it would be that one product, right? The only product in the list would have to be the cheapest product. It's also the biggest product. It's the cheapest element and the most expensive element by definition because it's the only one. So when we're looking for the smallest or looking for the largest, the default value of your answer is going to be the first element in the list. Every time. You always just start defaulting with the first element in the list. So we use stuff.getZero. We get the value at index 0. We store that in our answer. So by default, our answer is which product is the cheapest? The first product is the cheapest. Then we loop through. We check each product. We compare it to our answer because our answer is currently the cheapest product we've seen so far. If product P has a price less than the cheapest product we've seen so far, then P is actually the cheapest product, and we change our answer to be P. Okay? So what happens if there's a tie for the lowest? What if there's two products with the lowest price? A method in Java can only return one thing. We can only return an answer. We can't return many answers. So if there are a tie, then you can return either one of them. So this method only really cares that it gets a cheapest product. So if there's many of them, as long as you return one of them, you're going to be fine. In this particular example, if there's a tie, we will return the first one we find. Because if P's price is the same as answer's price, then P's price is not less than the answer's price. So this if statement would be false. We will not change the answer to P. So answer will remain the first cheapest price that we find. On the exam, if you're asked a question like this, it will include a sentence in there that will basically say, if there's a tie, it doesn't matter which one you return. Because you could rewrite this code such that it returns the last smallest value or the first, this is the first smallest value. It won't matter which one you return as long as the one you return meets the requirement. So this is the algorithm for that. And notice all of these searching algorithms are effectively the same. The only thing that's changing are the details of how you declare the answer variable, what's its type, and what do you default that value to. The condition you're checking changes slightly, and what you do to answer if that condition is true changes slightly. Besides that, the algorithm is basically the same. So if you learn this algorithm, if you memorize this structure here, whenever you have a problem where you're looking for something in a list that meets a requirement, or you're counting how many things meet a requirement, or looking for the biggest or smallest thing, it's just how fast can you write this down. There's very little you have to think about if you know the algorithm. And that's it. That's how you search a list for something. So if you're given an array list and you have to answer any of these three questions, does it contain an element that meets the requirement? How many meet the requirement? Or what is the biggest or smallest? Then you create a variable to store the answer, default it to something that makes sense, iterate over each element of the loop using your for each loop, or each element of the list using your for each loop, use an if statement to check if that element meets the requirement, whatever the requirement is. This is often going to require you to call a method on that element. It's very rare that you're going to be given a list of numbers and just comparing numbers. You're most likely going to be given a list of objects, and you'll have to use a method from that object to do that comparison. So like we were doing, call the get price method or call a get height method or whatever. You'll have to look at what methods that object has available to you, which is why those particular questions will give you some code describing what methods these objects have. Then it will give you more code with a list of those objects that you're manipulating. And then finally, you return your answer. And that is the searching algorithm. And that is computer science.